Let us begin our experiment with experiment number 1, which is Introduction to Measurement and Statistical Error. Here we will be familiar with different types of measuring instruments, for example, a meter rule, a vernier caliper and a screw gauge, and we will be measuring the volume of a cylindrical rod using these different types of measuring instruments. In this first part of the experiment, we will use a meter rule or a scale to measure the length and the radius of the cylindrical rod. As all of you have used a meter rule or a scale, we all know that we can measure up to 1 decimal places or 0.1 centimeter of accuracy with a scale, whereas using a vernier caliper we can do furthermore up to 3 decimal places. So in our first experiment, we'll measure the length and the radius of the cylindrical rod. The cylindrical rod we will be using will give us some different values when we measure it from different sides. As we know, this is not a theoretical one we are using, which has the same height and the same radius. So when we measure these using different instruments, we'll have different results or different values. To verify the differences, we'll be using these 3 types of instruments today. So first, we will use the meter ruler measurement, where we will measure the length, which is the height, you can say, the radius, which is from the top, and we will take these 6 values and we will do the average. So let us begin with a ruler measurement. Here, using the centimeter scale on the top, we'll place the cylindrical rod, align it with 0, and we will see up to how much it goes. So it's roughly 5, but not more than 5 or 5.1 centimeter. So as this has an accuracy of 0.1 centimeter, we can take more than it is showing. So we will write here 5 centimeters. Similarly, again we will rotate the rod. We'll place it again, align it with 0. We'll see this again. So we can see that this time it also came around 5 centimeters. So we will do on measuring the rod. Secondly, to find the radius, we'll take the top or the bottom part of the cylindrical rod and we will align it with the scale again, but this time we will firstly find the diameter and divide it by 2. So here on the centimeter scale, we place the rod here, align it with 0, and we get a diameter of 0.6 centimeters. So dividing it by 2 gives us a radius of 0.3 centimeter. Same way, let's rotate the rod and again let us try it out. So it gives us 0.6 centimeters of diameter again. As we are using a ruler measurement which has a accuracy of places or 1 decimal places, we can say that we won't find much differences as we continue. But using the other instruments we have now, we will see how the differences start to show up as they have greater accuracy. So for the second table, we will be using the vernier caliper to measure the length of the cylindrical rod. So let us get familiar with this vernier caliper. So this thing over here is a vernier caliper which has 2 scales. One, the big one which I am showing right here, is the main scale, and the small one with the numbers labeled from 0 to 9 is the vernier scale. And as you can see, the vernier scale tends to move. So there are 3 functions of the scale. Here we have an upper jaw, a lower jaw, and a rod shaped part which comes out and goes in. So they have different functions. For example, the upper jaws are used to measure the internal diameter of any object, and the lower jaws are used to measure the outer diameter or the length of any object. And lastly, this stick over here is used to measure the depth. We can just put it inside a liquid or something and we can measure the depth it shows on the scale. So to begin the experiment, we will have to find the vernier constant first. So what is the vernier constant? As you can see here, the main scale and the vernier scale have different values. For example, the main scale is like the meter rule used that has the label of centimeter. So here we can measure the centimeter and this one has an accuracy of 0.1 centimeters or 1 decimal place. But as we are using a vernier caliper, this has to have a greater accuracy, or else what would be the use of it? So to get 3 decimal places of accuracy, we have this vernier scale, and as you can see, they are labeled from 0, 1, 2 till 0. So they have 10 parts, and within this 10 parts they have smaller divisions. So we can say that they have a total of 20 divisions here. And the vernier scale, here we can measure smallest up to 0.1 centimeter. So vernier constant, we can clearly say that VC is equal to 0.1 divided by 20, which gives us around 0.005 centimeter. So to move on with the experiment, here we have to fill out table 2. So the first column indicates main scale, the second one the vernier scale and the length. So how do we find the length? So first of all, to find the length is equals to main scale reading plus vernier constant into number of divisions. So we already found the vernier constant. So what are the main scale readings and the number of divisions? The main scale reading is the reading we get from the main scale. So how do we calculate it, and how do we get the number of divisions for which we can find the total length? So let us put the rod over here. Like this, and we have a bolt over here. So let us just tighten it. So when we remove the rod, this part doesn't move. So let us see what the main scale reading is. So to find the main scale reading, we will consider this 0 for the reference point. As you can see, the 0 slightly crosses 5 centimeters but does not get onto 5.1 centimeters. So we cannot consider 5.1 centimeters for the main scale reading. So for the main scale reading, we will take the value that is closest, or that is before 0, not after 0. So for the main scale reading, we will be getting 5 centimeters. So over here, we will write main scale reading to be 5 centimeters. For the vernier reading, we will take the number of divisions. Let us look again. To take the number of divisions, we have to find which line aligns with the main scale line. So as you can see over here, that 0 doesn't align, 0.5 doesn't. So this way I can see that 3 aligns perfectly with the main scale. So 0, 0.5, 1, 1.5 till 3. So the number of divisions over here is 6. So we write the number of division to be 6 and multiply the vernier constant. So we get a value of 0.03, and the length is, we add up these two, so it becomes 5.03 centimeters. Again, for the second reading, we again put the rod over here and close the jaw. We tighten up the bolt, remove the rod, and again let us check what it is. So now, as you can see, the main scale reading is again 5. We write it down. Now for the vernier reading, this time 3 doesn't align perfectly with the main scale. So I can say that 2 aligns perfectly with the main scale. So the number of division for 2 is 4, and multiplying it with the vernier constant gives us 0.02. So we can say the length is 5.02 centimeter. See, when we take up to 2 decimal places, the value changes. Using the scale, we only got up to 1 decimal place, but using a vernier caliper, we are getting much greater accuracy. So we will continue down and take up to 6 readings, and we will find the average. So for the next column over here, where it states L bar, which is the average of the length, minus L of subscript of I whole square. So subscript of I actually represents the number of reading. So here you will get the average minus this reading whole square, and we will write it down here. Similarly, we will calculate all the other values we get, and lastly we find the standard deviation of the length. So what is the formula of standard deviation? We got all these 6 values. So standard deviation, we will find that by root over summation of L bar minus L of I whole square divided by n minus 1, where n is the number of readings for us, which is 6. And using this formula we can find the value of the standard deviation. For the last part of the experiment, we will measure the diameter or the radius of the cylindrical rod using a screw gauge. So we are using a screw gauge to get a higher accuracy than the scale or the meter rule. So what are the parts of the screw gauge and how do we measure them? So first, this part is called the ratchet, which we use to move the circular scale. The one that revolves or rotates around here is the circular scale. And as you can see over here, this small part or the one coming out is the main scale. So using the ratchet, we move this part and we create an opening where we can put the cylindrical rod over here to measure the diameter. To start the experiment, first we have to find two of the things, which are least count and the instrumental error. So what is least count? Least count is the least number of value we can take using the screw gauge, which is 0.01 millimeter, or we can simply say 0.001 centimeter. So up to 3 decimal places we can take using a screw gauge. To find the instrumental error, we will determine what is the number of the division. So the circular scale over here has 50 divisions in total. So as you can see here it is 45. So this one is 48, 49. Let's check it here again. It's 48. So we take the number of divisions to be 48 and we multiply it with least count. So using this value we find the value of the instrumental error. So as this is not perfect and as the 0 is above the main scale, we will add this value and we will get the correct result for the diameter or the radius. If the 0 was below the main scale line, we would have subtracted the instrumental error likewise. Let us start our experiment now. So first we have to fill out these columns. The first column is for the linear scale reading, secondly the circular scale reading, then we add this both reading to get the diameter, and then we take the instrumental error, where the instrumental error is this value we got by calculating it from here, and we subtract it with the diameter and we get the correct diameter over here. And after getting the diameter, we just divide it by 2 to get the radius, and the mean radius is the average we take for all the 6 readings, and this value is the one we did like in the vernier caliper part, and later we find the standard deviation. So let us start. We move the ratchet over here so it creates an opening over here. We place the cylindrical scale rod, and we tighten the ratchet. See, it doesn't move, it slides over, and here we have a lock. We just use the lock to make it stiff so it doesn't move from where we locked it. Now here from the main scale reading, as you can see here, we have 0 to 5. So the upper reading gives a reading of 0.1 centimeters, and the lower one gives the half of it, which is 0.05 centimeters. So here we have 0.1 centimeter, 0.2, 0.3, and as you can see over here it goes up to 0.6 centimeters. So the linear scale reading will be 0.6 centimeters of the diameter. Next, to find the circular scale reading. Here the value of the circular scale or the number of divisions we can say here 45, 46, 47, but here we see that it did not cross 47, so we take 46 divisions. So 46 divisions into least count gives us the value of the circular scale, which is 0.046 centimeters, and we add both of them to get the value of the diameter 0.046. Here you can see we got a value of 3 decimal places. While using a meter rule, we only got a value of 1 decimal place, so this one gives us a better accuracy. For the second part, or for the other results, let us take the rod over here in another part and we lock the ratchet here. As you can see from over here, we got a value of 0.6 centimeters again, but this time the circular scale reading is different. We can say it to be around 45. So multiplying this circular division with the least count gives us 0.045. So the total diameter is 0.645. See, the values differ as we move the cylindrical rod from one place to another and take readings. So this way we take 6 of the readings, we take the instrumental error which is 0.048, and later we just add this up with this value. So let us add it up. Which gives us a reading of 0.694, which is the corrected diameter, and then we divide it by 2 to get the radius. We take all the 6 readings of the radius and we do the average here, and like the previous one, we take the average and subtract it with the initial value, number 1, number 2, number 3, and we take the values here, and using the formula from earlier we find the standard deviation of the radius. Finally, after getting all the results for our experiment, we do the question answer. So the question answers are quite simple. First of all, we have the ordinary ruler volume of the cylinder. We have the formula for volume. We use the average values we got using the scale or the ordinary ruler to find the volume, where V is equals to pi r square L, where we take the average R and the average L. Later, on the vernier and screw gauge, we got the length from the vernier caliper and the radius from the screw gauge. We take the mean values from both the part and we find the volume over here. And later we find the propagation error. The formula is given on the lab manual, so you can follow the formula and find the value over here. And so on, we carry on all on the other questions and complete the lab.